Okay, so let's say you have y equals x squared plus 5. And it'll give you an interval, like it'll say 0 to 2. And then the problem's going to tell you like n is 2, or it might say the change in x is 1. Okay, so what all that means is find the area underneath this curve from 0 to 2. The n means make 2 rectangles. The change in x means the width is 1. Okay? You won't be given both those. It'll either say what n is, or it'll tell you what the change in x is. And if it tells you there's 2 rectangles and you're going from 0 to 2, how many rectangles are you going to make them equal width? There's 2. How wide are they going to be? 1. So that's where the change in x comes from. Okay? They're not going to give you both of those because you can figure it out based on the interval that you have. Does that make sense? Alright, so first thing we got to think about is we've got to draw this. And you know what? I want that to be a negative, so put that back on there. Put the negative x squared plus 5.
Like if it's positive, what do you have to do?
Okay, so since we're making 2 rectangles, I need to figure out how high to make these rectangles. And the height of the rectangles are going to be the y values of the function. Okay? So, I'm going to make a table with 0, 1, and 2 on them. Because I know if I'm going to have a rectangle, I'm going to have one of them from 0 to 1 and one of them from 1 to 2. Okay? I'm going to plug those values into the y value up there and just find out what you get. You get 5, 4, and 1. Does that make sense? Okay, we're going to graph it.
The points, right?
So the graph sort of looks like that right there. And we're trying to estimate the area underneath that graph. Okay, so one way that this Riemann guy said that he thought was a good way to find the sum, or to find the area, was to use what's called the left sum. Sometimes they call it the left-hand sum. Sometimes it's with a L and a H is the abbreviation because they call it a left-hand sum. What you do is you make a rectangle starting on the left of the graph. Okay? So I start over here on the left, so I start at 0. If that was 1 to 6, I'd start at 1. Okay? But I'm going to start at 0, and I'm going to make a rectangle as high. I've already figured out my width is 1, so I'm going to make a rectangle from there to there, and I'm going to come down to the x-axis. Does that make sense?
Yeah,
That's left.
That's left.
That is left. This is right. So there's my first one. Okay? My next rectangle, I go to the next y value and I make a rectangle that high.
From 1 to 2.
And it goes down there. So there's my 2 rectangles. That's called the left sum. So if I want to find the actual area, I just do the area of a rectangle. The first one is 5 times 1 because the width is 1. The second one is 4 because that's how high it is times 1. So our left-hand sum is 9. Is that an overestimate or an underestimate? It's an overestimate because you can look at it and tell that the part that we're trying to find the area of is above the graph. Okay? Another word they use sometimes is find an upper sum and a lower sum. You don't know if it's upper or lower. Like left is not always upper. It is here. This one's called an upper sum. You would just have to look at the points to decide which one would be upper and lower based on what the graph is doing. He said, well, there's other ways to estimate it. What if we found the right sum? Okay? So we're going to use the same points. We're going to graph it again. You can do it on the same graph. I'm graphing it again just so that you can see it better. And this time, we're starting on the right of the interval, 0 to 2. So that means we're starting at 2. And we're going to make rectangles that way. Okay? So I'm going to start over here at 2, and I'm going to make a rectangle that high. Then I'm going to go to the next y value on the right, and I'm going to make a rectangle that high. So that would be another estimate of what the area is. That's called the right Riemann sum. Sometimes they call it the right-hand sum. In this case, it's called the lower sum because it's underneath the curve. So if I find that area, this one is 4 high, it's still width of 1. The other one is 1 high with a width of 1. So we get 5. Alright, so on this right hand sum we got 5. On the left hand sum we got 9. And he said, well, if I find the left one and I find the right one, and if I average it, that's going to be pretty close. So sometimes it's called the best estimate. And if anybody asks me just estimate the area of the curve, this is what I would use. Okay? But you're just going to take 9 plus 5, divide by 2, you just average it. So our best estimate of what the area under the curve is using 2 rectangles is 7. So, same graph, we're just going to use the same graph just so that we can compare. Negative x squared plus 5. But this time, let's say that n was 4. Okay? We still want to go 0 to 2. So if I'm going from 0 to 2 and n is 4, how wide are these rectangles going to be if I have to make 4 of them in that interval? They're going to be a half. Do you agree? So what that means is when I make this table, I'm going to need the y values at every half value until I get to 2. I think I have them. I'm just going to go ahead and write them down. 5, 4.75, 4, 2.75, and 1. When you graph it, it doesn't have to be exact. Do the best you can. So there's 0, 5. There's going to be my half, my 1, my 3 halves, and so on. So at a half it's 4.75, so just a little bit below the 5. 1 is 4. 3 halves is 2.75. 2 is 1. It kind of looks like a line, although it's not a line, it's a parabola. Everybody good so far? So if I do the left-hand sum, I start at 0. And I make a rectangle. And then I go to the next y value and I make another rectangle. And I keep going until 2. So to figure out that same way, the height of the first one is 5, but this time the width is a half. The height of the second one is 4.75. The width is a half. The height of the next one is 4, the width is a half. The height of the next one is 2.75, and the width is a half. And you get 8.25 there. Okay, I'll write the right sum on the next page, but I'll go ahead and draw the picture for you. You're going to start on the right. I'm going to draw it on the same one just so I don't have to draw a new one. You can draw a new one or you can draw it on the same one. On the right, I would start at 2. And that would be like my far right rectangle. I would go to the next y value and draw it. My next y value and draw it. And my next y value and draw it. So the blue would represent the right sums because I started over there on the right to draw it. Okay? So I'm just going to go ahead and write what it would be, but it would be, if I start over there on the right, it would be 1 times a half because of the width, and then it would be 2.75 times a half, and so on. So I'm just going to write that down. you work that out, you get 6.25. So if I find my best estimate on this problem, which pretty much means I want to average this 6.25 and the 8.25 that I got on that one, I think it's 7.25. I had a different answer here. It was the same exact graph. What's the difference in the way I estimated it?
The number of boxes.
More boxes. Which one's more accurate, the first one or the second one?
Second one.
The second one. More boxes is going to be more accurate because there's going to be less like takeaway at the top and the bottom. Now, be careful whenever you're looking at some of the problems. Like I started at 0 here. Sometimes you might start at 1 and go from 1 to 3. So 1 would be the left. Okay, it's not always going to the x-axis. It just depends on the interval they give you. The video that you'll watch tonight is on midpoint and trapezoid sums, which sounds yucky. They're really not bad, but it's just 2 more ways that we could estimate. Instead of making rectangles, it's another way to make a rectangle that Riemann came up with, which was another way to estimate what the area was. Okay?